I'm Will Maden. I'm the Analytics Director of Morales Data. We're a tiny company based in Lancaster. We essentially data consultants, and then we build software off that consultancy. That's the sales pitch. I'm not going to talk about me anymore. Except that I started off, I did my PhD in Lancaster. I then went into, I did a bit of time as a lecturer and then as a consultant, and then I was a director in other companies. But all of these have been focused in logistics and supply chain, so that's really where I'm going to talk about. So I'm going to sort of try and take you through a system from manufacturing all the way through to delivery. It doesn't quite work because there's a few places where I haven't done any work, but you'll see. Right. So the first area is on about packing pallets. So this is really boring. Why would anybody be interested in packing a pallet? It's easy. You take things and you put it on a pallet. Well, if you're a transport provider, you actually want people to pack pallets really badly because they pay per pallet. So you get more money if they pack really badly. Except that that has a knock-on effect that if you have a really badly packed pallet, it often breaks the pallet, you can't get it off the transport, and the whole day's ruined. I spoke to one of our local hauliers, one of our customers, who went, yeah, that happens about twice a week. If you're a supplier, you want to get as much on a pallet as you possibly can. Both of which is sort of aimed at this approach. So how are pallets packed now? Well, it varies. Often there's a robotic arm that's packing it from one stack to another, and it uses clever modelling techniques to get that right. Maybe it just packs. The algorithms behind the robot are not necessarily always that smart. Sometimes it's actually a bloke that's got a packing plan and he's putting the items on the pallet. Often that pallet plan has been designed through this sort of modelling of data and is far more accurate than the robotic approach. Just an interesting technology there. How do we do it? Well, we take an item, we pack it into a layer, and then we stack the layers. It's nice and stable. Most people can do that. It's quite a straightforward problem. What we tend to do is go one step backwards. We look at the items rather than the packets. So inside that first green item, there could be 8 items. We've been given it in that packet, and then we've packed it that way. Well, what happens if we take that packet apart and change it? We've done that in the bottom one, and we've increased efficiency. So we will look back. So we will look back at the data that drives this model going back further and further. The next question, obviously, is can we go any further back? Can logistics have any idea about the design? Well, I did maths at school. My sister was the designer. She won't let me near anything that involves drawing a picture. She actually did all the graphics for this because I can't do it. So, no, I can't draw, but I can improve it. As you can see, this makes complete and utter sense. The dimensions of the current item are here. And all we're saying is if you move these dimensions down each into these different areas, you'll get more on the pallet. And you say, well, we can't change the dimension that much. Well, actually, if you can get it to the pink area, which is right at the very bottom, the change in one dimension is 4 millimeters and the change in the other is 8 millimeters. And if you can get it to that pink area, that's an extra 8 items on a layer, which is an extra 64 on the whole pallet, which is about 5% more efficient, which is 5% less pallets on the road. These are all basic, simple things. Who can benefit? Well, I love saying this because it's anyone who has a pallet can benefit. But in reality, if you move a lot of the same stuff all the time, you can benefit a lot from this. One of our successful customers was Mookie Toys. They saved £25,000 on a distribution run of one toy. Obviously, you all know Mookie Toys and what they're famous for. This one toy was a swing ball. Remember swing ball? £25,000 in just repacking swing ball on a pallet. We have many customers. I've just randomly picked 3. Diageo, Heineken. I can't think why they were in my mind, but I randomly picked 3, just to show that it works over multiple areas. So once you have the pallet, what do you do then? Well, pallets go into containers. Brilliant. Why do we need to pack containers better? Well, actually, the real reason we need to pack containers better is, have you ever tried packing a container? It's 3D Tetris, but it's worse because it doesn't match. The shapes don't match. The shapes don't fit. So, and a lot of people say, but everyone uses containers, so this must be a huge market. What's the advantage in moving someone from 3.4 to 3.3 containers? There's no real financial advantage. There never used to be. That's changing. So yes, it's an extension to pallet packing. This is using different shapes, different sizes. This is why it's changing. Shared use of containers. People are now, distributors in the UK are now ordering quarter container loads of goods from the Far East. And clever transport companies are merging these together. This becomes really powerful at that point because, again, the efficiencies of saving are huge. So, how are containers packed? Well, at the moment, typically someone just throws stuff into a container. I don't mean throw, they pack it into a container, but there's not necessarily a plan. We use smart algorithms, we model the data, we've come up with interesting processes. So this is the most important item we have to put in our container. We then pack around it with other goods. We always put the most important ones in, and then we're filling the gaps around it. That was my prettiness because I don't have a video. Again, who can benefit? Well, actually, this is a bigger market. Anyone who uses containers can benefit from this. This is such a huge area that people can get efficiencies and drive efficiencies from. Logistics at Glendimplex, who are electrical sort of fridge freezers, white goods people, they use our stuff, they shift stuff all around the world, from UK, Australian manufacturing plants all around the world. Weirdly, they claim benefits that I've not really thought of, but it gives a professional image. If you can tell someone how to pack a container, it makes you look more professional than if you just say, pack that, which I'd never thought of as a benefit. Warehouse simulations. This is really, hopefully really quick, because someone at the back is talking about warehouse simulations later, so I'm just going to be really quick, because we've done a little bit about them. So but the important thing to remember, and it seems to have got a bit lost in this process, is that simulation is not optimization. You cannot generate improvements through simulation alone. Well, you can, but they're slightly different. The operational benefits that are claimed from simulation are actually benefits that people have come up with and tried in simulations. Simulation is not optimization. It is a comparatively cheap solution to testing new ideas because, one, it's a piece of software, typically, rather than actually relaying a warehouse or something. And it's also cheap in terms of what happens if it doesn't work. You've not ruined anything. Warehouses are kind of a special place. I don't know if you remember KFC. Was it earlier this year or last year? When their warehouse went down, the knock-on effect was a long time. It goes down and it's felt. If it fails, it's felt immediately, and it takes a long time to recover. Simulation helps avoid those issues. It also, as this is the key benefit I think that simulations bring, other than relatively cheap comparisons, is that the operational benefits are often driven by just understanding the simulation. Just creating it helps people understand and talk about a problem. So what have we done? Well, we've simulated warehouses, we've relayed them out, and we've also talked about new investment within warehouses. Again, just a quick nod to the Ocado digital twin, who's going to talk about that. I think is even next as well. So, have you got that data, or do you want me to slow down a bit? Very quickly, again, vehicle routing. This is my area I grew up with this. This is what my PhD was in. But I know there's a workshop on it later. So again, it's just very quickly. It's just trying to show what benefits are out there if you model it and you treat it properly. The travelling salesman problem. Most people must be aware of that. Visit several locations. In this case, 8 locations, and returns to depot. This is a fairly easy problem. I think you can probably spot the easiest route. I mean, you start here, there. Just go around in a nice circle. But if you wanted to calculate all this, check every single one. There are 40,320 permutations. So it's, again, quite quick. The reason I point that out is everyone says, oh, Google can do that. That's an easy problem for Google. So yeah, that's an easy problem for most computers to solve. What happens if there are 100 locations? Well, there's 9.3 times 10 to the 157 permutations. Not quite so easy, not quite so quick. 1,000 locations, which is some of the ones that the vehicle routing stuff that we've been looking at. I put that into my calculator, it went NA. So how is vehicle routing? It differs slightly from travelling salesman. We have multiple vehicles. This is number of vehicles as well as different types of vehicles. So they can carry less, they can carry more. This is just to emphasise that the problem gets more complicated. Different vehicle types, just said. Time windows, each one of those dots could have a specific time that they need to be there. You're all used to that from a customer. Amazon's going to deliver you in this time window. Actually, you'd like that time window to get smaller and smaller and smaller. That time window getting smaller and smaller and smaller means the cost and inefficiencies go up and up and up, because you can no longer create those nice routes. Multiple depots, and particularly one of the ones we've done is with oil and petroleum, where different depots have different stock, so that adds another complication to it. Multiple objectives. Nowadays you can optimize for all sorts of things. My favourite one at the moment is emission reduction. I bought an electric car on the basis of emissions reduction, so I'm all for that. Typical saving. Again, this is, someone said, my partner said, you need to put typical savings on there. I was like, okay, somewhere between 0 and 25 is what I've experienced. Typically it's around 15, but if it's a complex problem, you can probably save more. If it's a simple problem, probably less. But there are significant savings. And bearing in mind some stat that I got the other day is it costs per year £250,000 for an HGV. So if you can reduce your fleet by one, that's a big saving. Just some of the customers we've worked with: Iceland Foods, that's home delivery. TNT and APC, that's parcel and package delivery. BCA, 2 points about BCA. One, we weren't actually scheduling vehicles for them. We were scheduling their drivers. You know the plate drivers that sit on the side of the roads asking for a lift? Yeah, we were trying to move those around. Again, a very different problem. And also, going back to a point that you made in your conversation about modelling being brought to the top table, I spent 18 months working as a director for British Car Auctions as the modeller in chief at the top table. I don't think I was that powerful, but I was at the table. But very finally, the last area I want to talk to, which is the most fun one, was logistics network modelling. What do I include in the logistics network? Well, all the locations for suppliers, customers, depots, and all the interactions between those sites. So what were we doing? Well, it's probably easier to give you a couple of examples. Well, this is one example. VPS and Evinder, I've got this written down because I need to get it right, otherwise it'll start the whole thing right badly. VPS and Evinder are two distinct businesses with a complementary mobile workforce. They were looking at rationalising their depot structure from an existing 42 sites while maintaining their existing surface level to customers. Their existing surface level was 85% service achievement within an hour. Evinder were locks and glazing, and VPS were shuttering. So if someone drunkenly smashed a window at 2 o'clock in the morning, one of these two companies would probably come out and fix that window. So what we did was we took a year's worth of data and we modelled it. What we did was we changed all the parameters. We said, okay, what happens if we have one depot? Where would it be? How would we service all the customers? How many vehicles would we need? How many engineers would we need? And we went, all right, scrap that. We've got 2. How do we do that again? And we built that up into a nice pretty map, the backdrop of which is the service level agreement. So you can see with one depot on the far left-hand side, you've got a fairly rubbish service level. But on the far right-hand side, you've got quite a good service level. And the line going through the middle is the cost. So even with one depot, the logistic cost is huge, which is why it's not suitable. But you can also see it's quite flat. The difference between sort of 19 up to about 28 was quite low, because the cost is shifted between the depots or the logistics. So we plotted where their current estimated operating costs were. So that was what they were. If you compare that to the line, you can see the inefficiency that they were currently operating, just from having the wrong sites or the wrong structure. We suggested that they move to 25, I think it was, sites. And we had a to and froing and changing of data. We started on the line and we had to move slightly away from the line for a couple of reasons: long leases on buildings, new leases that they just signed up for, or maybe modelling a location just down the road here, which obviously you can get warehouse space just around the corner, no problem. So again, it's just a slight deviation from the optimum. This worked out at about 20% annual logistics saving of the combined companies. So they were quite pleased with that. And just very finally, very quickly, just because it sort of counteracts almost everything I've just said, so I thought it's great to throw it in at the end. Europcar, you've probably heard of them, rental car company. We were looking at their cars coming off their fleet and going back to be cleaned and be sold, basically. They currently brought those back into 46 sites, and we reduced that down to 12. There was a slight problem with it. The logistics cost went up 18.5%. So we added 20% to the logistics cost. Yay, we weren't very popular. That's partly because the site saving was negligible, because they only had a site for them was a sort of land with a fence around it. So there was very little cost associated to it. However, the big cost that they had was a holding cost. So every vehicle that was in one of these sites couldn't be rented, couldn't be returned, and couldn't be exchanged. And their accountants worked out a range, but we managed to pin them down to a figure and say that we decreased that cost by 60%. So because we weren't just looking at logistics, we were looking at the whole package, we managed to save the lovely company about 15%. That's pretty much what I have to say. The only other things I'd sort of say is, this is where I fall out with my business partner, because he's all about, let's repeat work and make lots of money. Yeah, I get bored of that. I like interesting problems, really interesting problems, challenges, exciting things like that. If you have any, or if you know any, just please talk to me about it. That would be great. Thank you. If you have any questions, or we'll do that later. Brilliant.